Hello, welcome to Block 4, Place Value, Ordering Integers and Decimals, Lesson 17. I'll share my screen. So, in your previous lesson, you learned how to write negative powers of 10. In this lesson, you're going to learn how to write decimal numbers in standard form, otherwise in the form a times 10 to the power 10. Decimals contain negative powers of 10, so your knowledge of the previous lesson will be very useful in this lesson. But before we start, I would like to express a bit of surprise at what I am observing. Thousands of people are watching and learning from these videos, but they are not subscribers yet. So I would ask you for a favor. Please click on the notification bell, subscribe to the channel, click on the like button, subscribe to the channel, and click on the notification bell so that you will get informed when new videos are uploaded. Also, share the video. If you're benefiting, there are other children around the world that can benefit from these videos too. Having high quality education at no cost. If you do me this favor, my promise to you is that we will continue to upload high quality teaching videos to children around the world and to even adults who are interested in improving their math skills. Thank you. Before we start, I would like you to answer these retrieval practice questions in 4 minutes. Assuming you've paused the video and you've worked through these retrieval practice questions, here are the answers. Let's discuss them. Here, you were asked to mark the approximate position of 0.38 on the number line. If you think about it, 0.38 will make use of the fact that 0.38 will be greater than 0.35, which will be halfway between 0.3 and 0.4. So 0.38 will be closer to 0.4. Next, you were asked to solve this equation, 18x equal to 90. We can make use of the fact that we can divide both sides by 18 so that we can eliminate 18 from here. So we'll be left with our answer of 18 divided by 5, which is 5. We can also make use of the skill that we learned in previous lessons, that is some time ago, which is knowing how to use the function machine. So we know that we do not know the input. We know that we're multiplying by 18. That is what happens in the machine, because 18x means 18 times x. We know that our result is 90. So if we want to find the input, which we do not know, we can work backwards. Now, to work backwards means we're going to do the inverse operation of multiplying by 18. So to get the input, we'll divide by 18. So this is another way of thinking about the problem and finding a solution to it. Next, you were asked to continue the sequence. Well, if you remember, we did sequence quite a while ago. So that's why we call it retrieval practice. So here, to continue the sequence, notice that each time the number by which it increases by 1. So that increased by 1, that increased by 2, that increased by 3, that increased by 4. So if we follow that pattern, we will get these answers. Okay, let's do some new learning. So, if we have 0.001, we know that 0.001 can be written as 10 to the power negative 3. Also notice the pattern that I mentioned in our previous lesson. You see here we have negative 3 and we have 2 zeros before the 1. So if we follow the same pattern, if we have 10 to the power negative 5, for example, how many zeros would you have before the 1? Of course, it's going to be 4. So that will be 0.00001. Okay, so it's important for you to note that pattern because it's helpful to use less thinking process to think too much about, oh, what is 10 to the power negative 9? Of course, it's going to be 8 zeros before the 1. Now, if that is the case, how would we write this number? Well, 0.004 is the same thing as 4 times 0.001. So I want you to really take note of this. So 0.004 is the same thing as 0.001. Now, if we want to replace this with this, because remember 0.001 is the same thing as 10 to the power negative 3, we now have this. So we've taken this ordinary number and we've written it in standard form. So this is in standard form and this is an ordinary number, which is a decimal number. It's now time for you to do some practice with the little knowledge you have acquired. I would like you to write 8 hundredths in the form a times 10 to the power n. This simply means write it in standard form the way I showed you a few moments ago. I'll also require you to write 5 times 10 to the power negative 7 in ordinary form. Okay. Assuming you've paused the video and you've worked through this, let's discuss the solution. If we want to write 8 hundredths, 8 hundredths is the same thing as 8 times 0.01, because remember, 1 hundredths is 0.01. So 8 lots of that is 8 times 0.01. And I'm sure you notice the pattern that you just have 1 0 before the 1. So it's going to be negative 2. So we have, it's going to be 10 to the power negative 2. So this can be written as 8 times 10 to the power negative 2. To write this as an ordinary number, it is important for you to know that 5 times 10 to the power negative 7, if you recall from our previous lesson, 10 to the power negative, the negative power means you're dividing by 10 that number of times. So 10 to the power negative 7 means 5 divided by 10 up to 7 times. That means if you take note of the pattern, the way we write the negative powers of 10 in decimal form, it's going to have 6 zeros before the 1. So this is the same thing as 5 times 0.0000001. Of course, you know it's going to be this. It's now time for you to practice questions 1 to 4. Okay, so what you've learned so far is you are using the fact of how to write negative powers of 10 to be able to write decimal numbers. So here are questions 1 and 2. Pause the video and answer questions 1 and 2 in 4 minutes. Assuming you've paused the video and you've worked through questions 1 and 2, here are the answers. Let's discuss them. Here, you were asked to write the missing number and power so that these numbers are written in standard form. So by now, you know how to write these in standard form. So spot the pattern. You see that has 3 zeros before the 4. So you're going to have power negative 4, right? Here, that's negative 1. And here, you see, you have 5 zeros before the 2. So it's power negative 6. It's very important you make use of this pattern and take note of this. You have 3, 3, 3. Okay. You have 10 zeros before the 3. So it's going to be to the power negative 11. Here you asked to write these as ordinary numbers. So you have these, and so we follow the same pattern. All right. So you see that's power negative 5. So we'll have 4 zeros before the 8. Pause the video and answer question 3 in 3 minutes. Assuming you've paused the video and you've worked through question 3, here are the answers. Let's discuss them. Here you were asked to write these numbers in standard form. Again, we're using the pattern. We now know the pattern between how many zeros we have before the number and the negative power that we're going to use. Okay, so here are the answers. Okay, 6 divided by 100,000. Of course, that is the same thing as writing 6. You can see we have, yeah. So 6 divided by that number of, so it's like saying 6 divided by 10 up to 5 times. So you're going to have 6 times 10 to the power negative 5. 200ths is the same thing as saying 2 divided by 100. So that will be 2 times 10 to the power negative 2. 5/10 is the same thing as saying 5 divided by 10. So you're going to have 5 times 10 to the power negative 1. And so on and so forth. Now, note this because this is important. We're going to use this knowledge. We're going to use this knowledge in one of the questions or in one of the examples. So if we have 0.000004 times 100, this is the same thing as saying by the time we multiply by 100, we would have improved the place value of this number. So it's a bit like saying we're going to knock off 2 zeros. So 0.000004 times 100 will improve the place value of this number. So that will go away. So we now have this. Now take note, we have 3 zeros before the 4. So we're going to have power negative 4. Remember that pattern I showed you. And then this is 0.02 to the power 3. 0.02 to the power 3 is the same thing as saying 0.02 up times by itself or multiply by itself up to 3 times. Now, if we multiply the 2's, we have 8. Now, you can see that this, we could have rewritten this in standard form to say, okay, this is hundreds, 200ths. So it's like saying 2 times 10 to the power negative 2 times 2 times 10 to the power negative 2 times 2 times 10 to the power negative 2. Now, when you multiply the 2's and you multiply by the number of these negative powers, you will have 10 to the power negative 6. Here, 9 billions is a bit like saying 9 divided by 1 billion. And you know 1 billion is 9 zeros. So it's the same as saying 9 times 10 to the power negative 9. Let's move on. Pause the video and answer question 4 in 2 minutes. Here you ask what is the same and what is different about each set of numbers. Well, here are the answers. So here, the power of 10 is the same. The integer is different. So you can see them there. And then here, you can see what's the same and what's different. Okay, let's move on. Let's look at another example to prepare you for the next set of practice exercises. If I give you these numbers, which numbers would we say is closer to 1? Well, we can start by using an elimination method. So we find out numbers that are too big and then we cross them out because we agree that those numbers are too big than 1 anyway. So here you can see that that number is 700. And here we can see that that number is even a lot larger than 700. So those numbers wouldn't be closer to 1 than these numbers. So we can cross them out. So we now focus on these two numbers. 2 to the power negative 7 can be written as 0. You note the pattern, we'll have 6 zeros before the 2. And then here, you note the pattern, we'll have just 1 0 before the 7. So it's 0.07. So it's clearly obvious that this is closer to 1 than that. Here is another question. Sometimes you get problems given to you in words to solve. So 1 cent coin weighs 4 times 10 to the power negative 3 kilogram. What is the mass of $1 worth of cents? Give your answer in standard form. We're going to make use of the fact that there are 100 cents in $1. So if there are 100 cents in $1, it means to get the weight of, or to know the mass of 100 coins, we're going to multiply this number by 100. It's useful to make use of our place value chart, but we're going to write standard forms in the place value chart and use our counters to help us know how we move the place value as we multiply by 100. So here is what the place value chart translates to or means when we write them in numbers. So thousands is that, hundreds, tenths, and ones. And then if we write them in standard form, this is what we'll get. So you know the pattern by now. It's not a challenge for you to write from this to that, okay? From ordinary number to standard form. Okay, we have 4 lots of 10 to the power negative 3, so we put 4 counters there. But take note that we need to multiply by 100. Well, if we multiply 4 thousandths by 10 in the first instance, we're going to get 40 thousandths. But if we exchange 10 thousandths with 100ths, we're going to have just 1. So it means we'll have 4 counters in the hundredths place. If we multiply by 10 again, 4 hundredths will become 40 hundredths. Now remember, 10 hundredths is equal to 1/10. So if we exchange 4 of those 10 hundredths, we're going to have 4/10. So when we multiply this by 100, we have 4 times 10 to the power negative 1. Remember one of the questions we looked at previously when we were answering the questions in the practice exercise before now? We can think about it another way. So we have 4 times 10 to the power negative 3. If we write this as an ordinary number, this is the same thing as, you remember the pattern now, we have negative 3. So we're going to have 2 zeros before the 4. So this is 0.004. Now we've been asked to write this as an, we need to multiply this by 100. So if we do 0.004 times 100, the 100 that we're multiplying by will improve the place value of this decimal number. So if we cross that out, we can cross this out. So it means we have 0.4 as our answer, which is the same thing as this. Okay. It's now time for you to practice using the next following questions. Pause the video and answer questions 5 and 6 in 4 minutes. Assuming you've paused the video and you've worked through the questions, here are the answers. Let's discuss them. Here, to solve the equation, you have to divide 9 by 100. You remember? We saw a similar problem when we did the retrieval practice. So 9 hundredths will be 9 times 10 to the power negative 2. So 9 divided by 100 will be 9 times 10 to the power negative 2. Spot the pattern? Here is going to be 4 divided by 10,000. So we have 4 zeros. So 4 divided by 10,000 will be 10 to the power negative 4. So 4 times 10 to the power negative 4. And then here we have 6 divided by 2,000. 6 divided by 2,000 is the same thing as saying, well, what if we simplify this? So if we divide by 2, this will be 1,000. And if we divide by 2, this will be 3. So this is the same thing as 3 divided by 1,000. Now, 3 divided by 1,000 will be 3 times 10 to the power negative 3. You spot the pattern? That's good. Well done. Next, you were asked to circle the number that lies between 4 times 10 to the power negative 4 and 3 times 10 to the power negative 4. Well, the only number we can see here, thinking about the negative powers of 10 and how we write, you see, we have 3 zeros because we have to the power negative 4. So when we're writing it, we're going to have, so if we were to write this, this will be 0.0004. We have negative 4, so we're going to have 3 zeros before the 4. Then we have 0.0003. So clearly, the one that meets this criteria is this number. Pause the video and answer questions 7 and 8 in 4 minutes. Assuming you've paused the video and you've worked really hard through this, here are the answers. Let's discuss them. For question 7, you were asked to find the next 3 terms in the sequence. Now, all you do is you could have written this in standard form so that you know exactly the pattern. So this is -1. You see, this is -2. All right. This is -3. So you see the powers are increasing, okay, as well as the number that you write before the negative powers of 10. All right. And that's what is going on here. Here, you were asked to find the value of A if B is 5 times 10 to the power 2 and C is 2 times 10 to the power -1. Well, we are bringing our skill that we learned earlier on. That's the skill of substitution. So if you do not know how to do substitution, please go and watch that video. So we're going to replace these letters with the numbers. So here, 2b will be 2 times, b is 5 times 10 to the power -2. So we'll do 5 times 10 to the power -2. And then we're adding 2 times 10 to the power -1. 2 times 5 is 10. So we have 10 times 10 to the power -2. Now, if we want to put this in standard form, remember 10 to the power -2 is the same thing as, so this will be the same thing as 0.01. Remember? Now, multiplying by 10 will improve the place value of this number. So that crosses that out. So this is the same thing as 0.1. Now we have to add this. Remember, we write this as an ordinary number. This is the same thing as 0.2. Right? You remember? Yeah. So 10 to the power -1 is a tenth. So this is the same thing as 0.2. So now this is the same thing as 0.3, which we can write as 3/10, which is the same thing as 3 divided by 10, which is the same thing as 3 times 10 to the power -1. So it's a very important exercise that you can go over again. You can study again the way I wrote the solution. Here are questions 9 and 10. Pause the video and answer the questions in 4 minutes. Here you ask, a printer's paper tray is 5 centimeter deep. One sheet of paper is 8 times 10 to the power -3 centimeter thick. What is the maximum number of sheets of paper that can fit in the tray? And here is the answer. So if it's 5 centimeter deep and one sheet of paper is that, well, to be able to find the number of the amount of that is, you can do 5 centimeter divided by this amount. Okay, that will give you the number that you need. And then here, you ask 5 numbers have a median of this. The range of the numbers is this number, 0.35. So 5 numbers have the median of 9 times 10 to the power -2. And then the range of the numbers is 0.35. One of the numbers is 0.1. We're required to write the 5 numbers. Well, remember, what did we say we write median as? We start from the lowest number, we write to the highest number, and we pick the middle number. So if 5 numbers have this median and the range of the number is 0.35, we can pick numbers where if we subtract the lowest number from the highest number, we're going to get 0.35. That's how we work out the range. And then if one of the numbers is 0.1, we can write the numbers out. So 0.1 is the same thing as 1 times 10 to the power negative 1. And here are the answers. Okay, I do not want to make this video too long, so I won't be spending time discussing this solution. That brings us to the end of our lesson. So in this lesson, you have learned how to write decimal numbers as decimal numbers in standard form. You made use of the facts that you learned in the previous lesson, which is knowing how to write or express numbers as negative powers of 10. Until next time, take care and bye-bye.